All right. So, lesson 6.3, interpreting vertex form and standard form. Now, if we really want to get into it, first we have to understand what vertex form and standard form of a quadratic function are. Okay? So, let's give it a shot here. F of x equals ax squared plus bx plus c. Which form is this? Standard form. This is standard form. And f of x, I kind of give it away now. X equals a times x minus h squared plus k would be what? Vertex form. Okay? So we have vertex form and we have standard form. Now, no matter what, we know that a quadratic function, no matter what form it is a polynomial. And what is the degree of the polynomial for a quadratic function? 2, which means it's got what kind of term? An x squared. If it does have an x squared term, it's possible that it's a quadratic function. Okay? But if it doesn't have an x squared term, it's definitely not a quadratic function. Let me repeat that. If it doesn't have an x squared term, it is not a quadratic function. Simple as that. Okay? Because in order to be a quadratic function, it has to be a polynomial of degree 2. The only way for it to be a polynomial of degree 2 is if it's got an x squared term. Is that clear? Okay. So with that, we start our lesson. So it first says identifying quadratic functions from their graphs. All right. So it's the first one. It says graph the function x plus 1. So I'm going to go here, Desmos. So we're going to pretend we don't know exactly what I just said to you. Do you have a pass, young lady? Is it excused? Thank you. Oh, it's just got nothing in there. Okay, 4, 12. Okay, that's interesting. We'll have to talk after class. Okay, so let's pretend we don't know what I just told you, and it says use a graphing calculator to graph x plus 1. Well, I don't have a graphing calculator. I have something better. It's called Desmos. Now, first off, what does a graph of a quadratic function look like? What's it called? Parabola. A parabola. Okay, so is that a parabola? No. So is x plus 1 a quadratic function? No. It would have to look like a parabola. But what else do I know about this that makes it not a quadratic function? What does it not have? X squared term. So this is definitely not. So is not a quadratic function. And we know that for 2 reasons. 1, because it doesn't have the x squared term. And 2, because the graph is not a parabola. Does that make sense? Okay. So let's all close our computers, guys. Unless you're taking notes on it, which shouldn't be very many people here. Okay, because we should be filling out this book right now. Bam. You see that? That's right there in your book. All right, next one. X squared plus 2x minus 6. Based on what I told you, is that going to be a quadratic function? Yeah, it sure should be. Let's see. X squared plus 2x minus 6. Is that a parabola? Yeah, so is that a quadratic function? It sure is a quadratic function. Okay. Next one, 2 to the x. Is that an x squared? Is 2 to the x the same thing as x squared? Sure is not. So should this be a quadratic function? No. In fact, it's called an exponential function. And let's take a look at the graph. Is that a parabola? No, that's not a parabola. So 2 to the x is not a quadratic function. Simple as that. Okay, moving on to page 240. See, we're getting familiar with quadratic functions. F of x equals 2x squared minus 3. Does that have an x squared term? Yes. Yes. So is that a quadratic function? Yes. Yeah. Okay. All right. Now, before I just go on with that statement, right, one is an example of a function that has an x squared term that is not a quadratic function. Just pay attention. Don't take this down in your notes. What if I have something like this? X cubed plus x squared plus 3x minus 1. What kind of polynomial? What's the degree of that polynomial? 3. Okay. Does that mean is that a quadratic function?
No.
No, it has to be a polynomial of degree 2. But wait, Mr. Munir, it's got the x squared term. Yes, but that is not the highest exponent. This is the highest exponent, and that's what determines the degree. Does that make sense? So that's an example where it has the x squared term, but it's not a quadratic function, you see? Because what really makes the difference is it has to be a polynomial of degree 2, and that's a polynomial of degree 3. Does that make sense? Okay, but the easiest way to first check is like, does it have an x squared term? No, it doesn't. Well, it's definitely not a quadratic function. But if it does have an x squared term, you have to make sure it doesn't have any exponents that are higher than that, or fractional exponents or something like that. Yes, sir.
What is the name of this graph?
This graph? That's a cubic function, and it just doesn't really have a name like that. Sorry. Thank you. Good question, though. Okay, so let's take a look, though, back here. 2x squared minus 3. Well, 2x squared minus 3, is that a parabola? Yep, so it is a quadratic function. And now we move on, and we've got here negative x minus 3 squared plus 7. What does that look like? It looks like a kind of form. Which form does that look like?
Vertex.
Vertex form. So is that a quadratic function?
Yes.
Yeah, so let's take a look. Negative x minus 3 squared, is it plus 7? Yeah. Is that a parabola? Yeah, sure is. So that's a quadratic function. So this is a quadratic function. Square root of x, does it have an x squared term? No, that's not even a polynomial, honestly. Okay. There you go. Is that a parabola? No. So this is not. Okay. Reflect. How can you determine whether a function is quadratic or not by looking at its graph? Someone raise your hand and tell me the answer to that. Marley. If it's a parabola. Exactly. So if it is a parabola. Okay. Discussion number 2. How can you tell if a function is a quadratic function by looking at the equation? Yes, sir? Yeah, sure. Yeah, it really the most accurate way to say it is a polynomial of degree 2. Because there are some instances where that would be the highest exponent. For instance, like this, f of x equals x squared plus 2x to the 1/2. Okay? X to the 1/2, remember, is the same thing as square root of x, right? But is this a polynomial? No. It's not a polynomial because that's not a whole number. A polynomial has to have whole numbers that are positive, right? Like 2, 3, 4, 5, 6. It can't be 0.8. It can't be 1/3. It can't be -6, right? In order for it to be a polynomial, it has to have positive whole numbers as the exponents. Does that make sense? Okay. All right. Very good. So a polynomial of degree 2. All right, good. Now, identifying quadratic functions in standard form. Now, standard form is what we started with, okay, when we started talking about quadratic functions, but then we backed away and went to vertex form. Okay, but let's kind of talk about this here for a second. If I have f of x equals a times x minus h squared plus k, where's the vertex of that function? hk. That's why it's called vertex form. It's very easy to determine where the vertex is. But if I have something in standard form, ax squared plus bx plus c, there is no hk, so I have to figure out how to find the vertex. Well, fortunately for all of us, there were some mathematicians that figured out that the vertex, when written in standard form, the vertex is as such. The x component is negative b over 2a. What does that mean? Whatever b is, whatever a is, I plug them in, and I get the x component. Okay? That makes sense? And that'll just be a number, right? Like 4 or 3 or 1/2 or something like that. Got it? Now, whatever I get for that x component, if I have an x value and I want to find the y value, what do I do with that x value? Plug it in, right? So I take whatever that x value is and I plug it into my function. And the way we show that is f of negative b over 2a. Does that make sense? So whatever this is, I plug it into my function to get my y component. Does that make sense to you guys? Yeah? Any questions on that? Yeah, that's exactly what we're going to do. All right, so let's do an example. So let's say we have f of x equals 2x squared plus 4x plus 3. Okay? Well, the first question, so you guys with me? If I want to find the vertex, the first thing I have to do is figure out what a and b are. All right? So what's a in this case? A is equal to 2, and what's b? 4. B is equal to 4. Okay. Now if I'm finding my vertex, I have to get negative b over 2a. Well, that's just negative 4 divided by 2 times 2. You see? Just plugging in b and a. You see that? Well, what does that equal? Well, it's negative 4 over 4, or just negative 1. So I know my vertex, the x component, I've just gotten it as just negative 1. You see? Does that make sense? Okay, so just negative b over 2a. Now everyone say it with me. Negative b over 2a. Ready? Negative b over 2a. One more time. Negative b over 2a. Now I don't have any songs for that necessarily, but just b2a. I don't know. Negative b over 2a. Negative b over 2a. If you sing it enough times, you'll remember it. Over 2a. Negative b. Yo. Oh. All right. Yeah. Getting funky. Oh, we can make like a Motown funky jam out of it. All right. So now that I've got the negative b over 2a, what do I do with that? What do I do with that value to get the y value? I plug in negative 1. And so I do f of negative 1. Well, that equals 2 times negative 1 squared plus 4 times negative 1 plus 3. That equals negative 1 squared is 1, so this is 2. Negative 1 times 4 is negative 4 plus 3. 2 minus 4 is negative 2 plus 3 equals 1. So there you go. Just plugged it in, and my vertex is at negative 1, 1. You guys got that? Does that make sense? Okay. Any questions on how we did that just now? Okay. All right. So let's do one on our own now. Okay. Let's go ahead. I'm going to do something a little bit strange here. I'm going to write the problem up. Oh, wait. I'm going to do the next one just right up here, okay, guys? So this is what you're going to do. I'm just leaving all this work so you can see how to do it. Okay, f of x equals 3x squared minus 12x plus 4. Okay, 3x squared minus 12x plus 4. And so you can kind of just follow along with this process here. get the vertex in the same way as we did. Negative b over 2a. Find the x component. Plug it in to get the y component. Simple as that. You guys a little bit more time. Okay, let's do it. First thing, what's A? Class, what's A? A is equal to 3. And what's B? Negative 12. So I do negative B over 2A equals negative 12 over 2 times 3. Well, negative times a negative is a positive, so it's 12 over 6, or 2, right? So my vertex, the x component is 2. So now what do I do with that 2? Plug it back in. So I get f of 2 equals 3 times 2 squared minus 12 times 2 plus 4, or 2 squared is 4 times 3 is 12, minus 12 times 2 is 24, plus 4. 12 minus 24 is negative 12, plus 4 is negative 8. Final answer. Is that clear? Yes, sir.
How come 2 is not negative?
Because it's negative b over 2a, so it's negative 12 over 2 times 3. So negative times a negative is a positive. Good question. Any other questions? You guys pretty clear on that? Okay, just negative b over 2a, and then plug that in. So negative b over 2a to get the x component, plug it in to get the y. Done. All right? Good. Now, let's continue. Shall we continue? Okay. Changing from vertex form to standard form. All right, I will accept that challenge. All right, here we see a function on page 242. Here we see a function written in vertex form, very clearly written in vertex form. How should we change that to standard form? Let me refresh your memory. Vertex form is f of x equals a times x minus h squared plus k. That's the form of that function, right? A, x minus h squared plus k, right? What I want to do is make it look more like this, or exactly like this, rather. Ax squared plus bx plus c. I want it to be in this form. What should I do? Yes? Simplify. Very good. Very good. Okay, so look. I'm going to simplify by squaring this out. Remember when we squared binomials? Square the first, square the last, multiply and what? Square the first, square the last, multiply and? Double. You guys remember that? Yeah. Square the first, square the last, multiply and double. Remember? Okay, x squared plus 2 squared is 4. Multiply 2 times x and double, 4x. You see? Minus 1. Okay? Square the first, square the last, multiply and double. Alright, if you have to, you can just FOIL it out, that's fine. But it's just so much easier to do that. Square the first, square the last, multiply and double. Alright? Now, what's my next step? Very good. Distribute the negative 3. We get y equals negative 3x squared minus 12x minus 12. And then minus 1 all the way in the end. And then the last step, combine like terms. So I have y equals negative 3x squared minus 12x minus 13. Is that in standard form? Yes. Sure is. There you go. Any questions on how we did that? All we did was simplify. That's it. Any questions? Okay. So I'll ask you guys to do one on your own now. Go ahead and do number 9. Number 9 on the bottom of page 242. And I'll leave that up so you can look at it. Okay. Let's give it a shot. Alright. First, I have to square that out, square that binomial. Y equals 2 times square the first, x squared, square the last, 25, multiply and double. 5 times x is 5x, double that, 10x, plus 3. Next step is to distribute that 2. So I get y equals 2x squared. 2 times 10x is 20x. Plus 2 times 25 is 50. Plus 3. And the last thing is I have to combine those two like terms. Y equals 2x squared plus 20x 2x squared plus 20x plus 53. And I'm done. Any questions on that? Any questions on how I did that? No? Okay. Yes. Okay. Now, the last real thing here is writing a quadratic function when given a table of values. Okay. All right. So let's say I give you this table of values here. Okay. -6, 9. Can someone read off the points for me, please? Jordan, will you do that for me? -6, 9. What's the next one?
-4, 1.
Okay. -6, 9. What is going on? -6, 9. -4, 1. Next one?
-3, 0.
0.
-2, 1.
-2, 1.
0,
0, 9. Right? Okay, so we can see here that we've clearly got what looks like a parabola, right? You guys see that? Okay. But just from the table of values, I didn't even need to really plot these points. Just from the table of values, which one would you say, which point would be the vertex? -3, 0. And how can you tell? Well, one, it's in the middle, and you can just assume that they're giving it to you that way. But two, what about the other y values? What are they across 0? They're symmetric, right? 9, 1, 0, 1, 9. So you know that would be the vertex, okay? All right. So we've clearly got a parabola going here, all right, with -3, 0 as the vertex. So how do we figure out the function based on this? Well, if I have f of x equals a times x minus h squared plus k, well, the vertex is where? The vertex is at hk. Well, if the vertex is -3, 0, then what is h? -3, and what's k? 0. Okay, so I plug those in, and I get f of x equals a times x minus -3, so it's x plus 3 squared, and then plus k is 0, right? Does that make sense? So I just figured out h and k, and I plug them in. All right? Now, I have my f of x, but I've still got this a here that I need to solve for. Who's got an idea of how I could solve for it? Yeah? I can't use a slope because it's not a straight line, right? It's a parabola, it's a curve. Yeah, Grant? No, that's what you're saying is like a slope. But how could I determine it? Do I have any other information that I could use? What information am I given? I'm given this whole table, right? Can I use any of those points? No? Michael, please put your computer away. So, thank you. Can I use any of these points? God bless you. Yes. Yes, I can. Okay? I sure can. I can use any of them. X equals -2 and f of x equals 1, right? If I plug those in, the only letter I have left is a, and I can solve for a. So let's go ahead and plug those in. 1 equals a times x is -2 plus 3 squared, right? Or 1 equals a times -2 plus 3 is 1 squared, or 1 equals a. There you go, right? So I solve for a. What do I do with that now? Plug it back into my function. And I end up just with f of x equals 1, so just leave it alone, x plus 3 squared. You see that? And that's my final answer. So what did I do? I plugged in my vertex for h and k, and I used another point to solve for a. Plug in my vertex for h and k, use another point to solve for a. It's a long one. But plug in your vertex for h and k, then use another point to solve for a. All right? Okay, but let's check if we got it right. It'd be pretty embarrassing if we didn't. Hey, look at that. See that? So we were right. Cool? Does that make sense?
Slightly long.
All right. Let's use this one. Let's use this one here. Go ahead now. Example B. Example B to solve, and solve in the exact same way. Okay. So example B. It's this one here. 0, 13, 0, negative 1, negative 2, negative 3, negative 4. Okay, use that to solve for a function in vertex form. Maybe about 30 more seconds. Remember, you just plug in H and K, and then use another point to solve for A. Okay. All right. You always start with the vertex form. F of x equals a times x minus h squared plus k. Okay, in this case, hk is negative 2, negative 3. So I plug that in, I get f of x equals, just to be clear, so h equals negative 2 and k equals negative 3. That's my vertex here. So f of x equals a times x minus negative 2 or x plus 2 squared minus 3. Okay, now I'm going to use another point to solve for a. Which point should I use? Which point would be wise to use? Negative 3, 1. It looks like the easiest, right? So let's use that. So x equals negative 3, f of x equals 1. So 1 equals a times negative 3 plus 2 squared minus 3. 1 equals a times negative 3 plus 2 is negative 1 squared minus 3. 1 equals negative 1 squared is 1. A minus 3. Add 3 to both sides. And I get a equals 4. Take that value, a equals 4, plug it back in for a. And I get my final answer is f of x equals 4. X plus 2 squared minus 3. And that's my final answer. Any questions? Any questions on this? No? Okay. So in your book it asks you It asks you to rewrite it in standard form, so it says go another step and rewrite it in standard form. I'm not going to ask you to do that because it just would make this problem super long. Okay, it's already enough work as it is. Yes. Good.
Yeah.
You good, Tyler?
Yeah.
Yeah. Okay. All right. So any questions on this? No. Okay. Your homework 1 through 22. Page 247, numbers 1 through 22. Okay. And I'm realizing now there's one part of it here that I didn't exactly cover. Look, if I've got something like this, it's asking to see whether or not the equation is quadratic. Look at number 7, everybody. I'm going to do number 7 with you. Okay. I just have to get y by itself first. I have to get y equals something first. So I subtract 5x squared from both sides and subtract 3 from both sides. I end up with y equals negative 5x squared plus 6x minus 3. Is that a quadratic function? Yes. So the answer is simply yes. But I have to solve for y first to make sure it's just a function. Okay? Any questions about that? No? Okay. Really good job, class. All right. Yes? Quizzes lesson 6.1 through 6.3. Okay. 6.1 through 6.3. Any more questions? Okay. You got a little bit of time to do your homework. Thank you very much for your attention.